Like a Hellcat.
Cars as we know them have been around since the early 1900s, but for over a century we have been burning fossil fuels at an alarming, almost careless rate. Only in the past decade have we seen the electric vehicle market really taking off. However, all EVs draw power from large battery packs placed deep beneath the car, hundreds of times the size of your latest smartphone's battery. Have you ever wondered what happens to them once the car reaches retirement age? A ban on petrol and diesel cars is fast approaching for many of us, meaning electric cars are becoming a much more common sight on our roads. An initial target of 2040 in Britain was brought forward to 2035, while latest estimates suggest Prime Minister Boris Johnson is considering a move as early as 2030. Other targets include as soon as 2025 for Norway and various European city centres, 2030 in India, Israel, the Netherlands and France, and 2040 in Taiwan and Germany. A further 8 US states, including California and New York, have made the pledge to reduce vehicle emissions to zero by 2050. Batteries have been a key part of motoring for decades now. It's what gives the starter motor power to ignite the engine. But these are a different type of battery, powered by lead acid. Right now, more than 90% of these batteries are being recycled, leaving behind very little trace. This is compared to the staggeringly low 5% of all lithium-ion batteries that are used in electric cars. That's right, 95% of these batteries are left unused, which has a devastating effect on our environment. Experts estimate that between 10 to 15 million tons of lithium-ion batteries will have been discarded by the year 2030. Electric vehicles are in their infancy and have years of catching up to do with internal combustion counterparts. But the progress is already starting, with Hyundai, BMW and Renault all committing to repurposing disused batteries into energy storage systems for the likes of power grids. Isolated cases of batteries being repurposed are beginning to emerge on a global level. Nissan is implementing streetlights, Chevrolet is backing up a data center, and Chinese-based automaker BYD is adopting energy storage, all from retired EV batteries. Hundreds of examples of uses can be found across the globe, but the race is well and truly on for somebody to come up with a standardized method which can be adopted by all automakers. And with his expertise in the electrical industry, could it be Elon Musk? Currently, Tesla is scrapping batteries to recover valuable metals and responsibly disposing of any remaining parts. But this is on a very small, localized scale, with batteries mainly coming in from its own manufacturing plants, such as retired research and development models. But why exactly should we be so concerned about the environmental impact of batteries? Can't they just be recharged? Not entirely. When a battery chemically ages, it loses maximum capacity, which results in fewer miles and poorer performance in EVs. Two primary battery types are used: NMC, which combines lithium with nickel, manganese and cobalt, and NCA, which swaps out the manganese for aluminium, as is used in Tesla's approach. Just like fossil fuels, these resources are finite, which means we only have so much of each left on this planet. So conserving and reusing them is the best option. And on top of this, with cobalt being mined in the Democratic Republic of Congo and lithium being mined in South America, it's likely that the vast majority of machinery is being powered by dirty sources like petrol and diesel. The goal then is that with time, battery recycling and therefore production using recycled materials will become cheaper and easier, allowing companies to reuse materials used in their batteries time and time again. Although the production of batteries can be quite heavy on the environment, Tesla CEO Elon Musk claims to have prevented 4 million tons of CO2 from entering our atmosphere thanks to the fuel saved by the 550,000 Teslas on the roads. The company has also generated 13.25 terawatt-hours of electricity from 100% clean and renewable sources, including 3.5 gigawatts of installed solar panels. Only about 40% of this energy, 5.26 terawatts to be exact, was used by Tesla cars on the road. In generating surplus clean energy, Musk is buying time by offsetting environmental drawbacks. Customers write online about their experiences of very little battery degradation. We're talking a couple of percent over almost a decade, and his company already expects battery packs to be lasting 300,000 to 500,000 miles, which already exceeds most average car lifespans. But on the road to 1 million miles of longevity, the company made somewhat of a breakthrough recently. A new design of battery has been engineered and is being prepared for implementation in a car for the first time. Several layers of energy-storing chemical compounds are required to make a battery, but the new tabless design allows electrons to travel less distance. For an electrical engineer, this is an edge-of-the-seat moment, which may be taught in future science lessons, but for the average consumer it means a better energy density, and for the environment it means fewer metals needed per mile of charge. An all-round benefit then. Creating the most energy-efficient batteries is the first step in tackling the environmental impacts of batteries. But the batteries employed in some of the first Teslas are now approaching the end of their lives, and it's time for Tesla to begin thinking of a process to achieve maximum sustainability. So far, the company recycles what it can and disposes of the rest responsibly. But CEO Elon Musk has proposed a closed-loop system in which materials circulate through various stages of life before reincarnating into the next battery. In the proposed closed-loop system, lithium, cobalt, aluminium, copper and steel will all be recovered from retired batteries. Drivers can take reassurance that not only is sending waste items to landfill not the right thing to do, but these precious metals are too expensive to dispose of, which means recycling is more cost-effective for companies, helping to prevent the rapid expansion of landfill sites around the world. And even if Tesla were to send batteries to landfill, we're told that all materials used are safe and non-toxic. Lead, mercury, cadmium, hexavalent chromium, PBBs and PBDEs have never been used in the production of Tesla batteries. Nevertheless, extracting elements from a product that has been put together in such a meticulous way has got to be a complex process. Some estimates place the figure of fully recycling a lithium-ion battery in the region of $1.20 per kilogram. That's about $650 for an 85 kilowatt-hour pack. Yes, that seems expensive at the moment, but as with any technology, prices are pushed down with the passing of time and new developments. And as yet, there is no globally recognized standard way to recycle a lithium-ion battery. But to develop a closed-loop system, or in other words, a system in which no new materials are added for the equivalent number of cars, Tesla is one of the first car companies to be making groundwork towards a net zero approach. Would you be more inclined to buy an electric car from a company that recycles its batteries?